In this video, I want to explore graphing linear equations in slope-intercept form. So first, as a review of slope, remember that slope of a linear equation is the rise of the equation divided by the run. And if we remember, rise is the vertical change, or in other words, how high the graph is going from one point to another. So from this point x1, y1 to y2, I can see that the change in y is going up 3. And the run is the change in x, or in other words, how far over we're moving horizontally to get to the next point. So I'd say the run is over 4, the rise is up 3. And we can actually get that by subtracting the y values of these points. Notice the y value here is 4, this is 1, 4 minus 1 is a distance of 3. And then same thing with the run, this is 4, this is 0, 4 minus 0, I get a run of 4. And that's what this y2 minus y1 over x2 minus x1 gives us for our slope. The key thing we want to remember, though, is that slope is really telling us how steep a graph is, right? How far up versus how far over we're going, and that this is the m value in our equation. The y-intercept is another point we see in our y-intercept, y equals mx plus b equation. And very simply, the y-intercept is the point on the line that falls on top of the y-axis. So I can see right here, this red dot is the y-intercept of this line because that's falling exactly on top of this vertical axis. We'd say that it occurs at 3. We want to notice that in the equation y equals mx plus b, that is this b value. So once we find the y-intercept, that b value, we can simply plot it on the y-axis. Now what I want to practice today is how to actually use these two values to graph a slope-intercept equation. So the first thing we're going to do, number 1 here, is if the equation is not already in that slope-intercept form, and just as a quick reminder here, the slope-intercept form is that equation form y equals mx, so the slope being m plus b, where the b is the y-intercept. If the equation is not already in this form, we can simply solve for y and put it into this form. After we've done this, we can identify the slope and the y-intercept, then plot the y-intercept, and then use the slope to find some other points based on that y-intercept that we plotted, and then we can simply sketch a line through these points. So let's see this in practice. In our first equation, I always want to check first if the equation is in y equals mx plus b form. So if I write this out directly below the equation, y equals mx plus b, I can see that yes, the equation that was given was already solved for y. So now I'm looking for the slope and the intercept. Very simply, I can see that the slope, which remember is the m value, is 1 over 2. And remember that means that the rise is 1 and the run is 2. So I'm basically going to the right 2 every time I go up 1. The other thing I need to identify then is the y-intercept, which is our b value. And if I look at this equation, I can see that the y-intercept is up 2. So very simply, I can see that the y-intercept equals plus 2. So if I sketch this y-intercept, I can see that that's telling me to go on the y-axis, up 2. So there's my y-intercept. Now from here, this slope actually tells me what to do, which is pretty nice. All I need to do is just follow the slope, which is telling me that the rise is up 1 and that the run is over 2. And then I can immediately plot my second point, which should be right here. And if I want to, I can even do this multiple times. So the rise here tells me to go up 1, and then again over 2 for the run. I can even get a third point, and I can do this as many times as I want. But I can already see that the line is beginning to form, and I can now simply sketch this line, just like so. So before we take this for granted, we found 2 other points off of the y-intercept based on our slope. So for instance, if I just highlight those really quick, we found this point 2, 3, and we also found this point 4, 4, just based on counting off of the slope, the y-intercept. I always think it's a good idea to check at least one of these. So for instance, I might want to check that plugging in 2 will actually give me the value 3 that match up with that ordered pair, just to make sure we didn't make a simple mistake. So over here we can write check, And again, this isn't a surefire 100% foolproof way to check it, but it's at least a good way to make sure that we were, for the most track, on the right path here. So if I plug in the x value of 2, y equals 1/2 times 2 plus 2, I can then see that 1/2 times 2 is 2 over 2, which is 1 plus 2. And since I know that 1 plus 2 is equal to 3, we are all set here because, don't forget, this does represent the ordered pair. I plugged in 2, I got 3, and that confirms that I do get this ordered pair. Notice if I plot that, the ordered pair 2, 3 is right here, that point that fell right on top of our line, so it looks like we did everything correctly. So if I want to try this again I want to check to see if it's solved for y, and it does appear to be solved for y. So I can immediately look for y equals mx plus b, our slope m and our y-intercept b. So if I write this out, this time the slope is equal to a -3/5. Now a lot of times people ask, how do I know which one to make negative? And really it's up to you. I can write -3 over a +5, which is what I'll write, or you can write 3 over a -5. It really doesn't matter. We're actually going to see how they both work. We'll start with the -3 and the +5 for rise and run. The only other thing we need now before we get going on our graph is the y-intercept, which is our b value, and if I look at our equation, our y-intercept is a +4. So if we plot these points, first I start with the y-intercept. That tells me to go up 4, which is good. And now I'm simply looking at the slope. This rise is -3. The negative implies that I need to go down 3. And then the run is a +5, implying that I need to go over 5, which would put me right about here. So this would be my second point. Now you notice at this point, I don't actually have enough room to go down 3 over 5 again. This is where we can go back to what I was mentioning earlier. I wrote the slope as -3 over 5. I could also write it as a 3 over a -5. Notice how both of these, a positive over a negative, is a -3/5. So in terms of drawing the slope, I also could have gone a +3 up 3 for the rise, and then a -5 for the run, or in other words, back 1, 2, 3, 4, 5, meaning I also have a point right here. And notice how these still fall all in the same line, right, all 3 of these. And I can now actually sketch that line, which would put me right about here. Okay, so again we found a couple points based on the y-intercept and the slope. I always think it's a good idea to check one of those. So how about we check this point 5, 1. Let's confirm that if I plug in 5 I get 1, just to see if we were on the right track. So again, I'll write that we're checking here. So check. And if we do this, and if I plug in that y value we were talking about, which was that 5, into our equation, I have that y equals -3/5. I'm plugging in the x value of 5. Our y-intercept is +4. And we want to confirm that we actually get 1 when we do this. Let's see if that actually happens. So if I do -3/5 times 5, that's -15 over 5, or in other words, -3 plus 4. And then I can confirm that -3 plus 4 is a +1. And this is good because this all confirms that I plugged in 5 and I got 1, meaning that that 0.51 that we were looking for, or at least that we found by using slope and y-intercept, appears to be true. So here's another example. Immediately I notice that there's an issue. This equation is not solved for y. And if I look here, I can very clearly see that it's 2y, not just y. So I need to fix this. But I can get rid of the multiplication by 2 simply by dividing both sides by 2. So that's not too big of a deal. All I need to do then is recognize that I get y equals negative 2 over 2 is a negative 1x, and negative 6 over 2 is a negative 3. All we need to do now is just plot these points and then sketch. So let's identify our key values. Y equals mx plus b. I can see I now am in these this key y equals mx plus b form. I can now identify that the slope, or in other words, the m value, is equal to negative 1. Now you might be saying, well, I've always used fractions. I don't know what the rise or the run is. Keep in mind, any integer can always just be divided by 1. So I can clearly see that the rise and the run are actually both just 1 here. And again, I can make either one positive or negative, as long as that we recognize the ratio has to be negative. So then the only other thing we need is the y-intercept, which is our b value. And if I look back to my simplified equation, it looks like that came out to be a negative 3, so this time I'm going to go down 3. So plotting that point, the y-intercept, it is negative 3, so I am going to be down 3 on the y-axis this time. And if I follow then the rise versus the run, the negative 1 of the rise is telling me to go down 1, and then the positive 1 for the run over 1. So I immediately have another point right here. I can keep doing this as many times as I want. Just do it a few more times. So I can actually go down 1 over 1. I'll even do it one more time. Down 1 over 1. And I actually then just got 2 more points that we can plot. I have this point at 2, negative 5, and another point at 3, negative 6. All of these are going to then start forming a line, which I can sketch pretty easily here. It's going to look something like this. Let's see if I can clear up that side a little bit. So there's a rough sketch of the line. And like always, it's not a bad idea just to confirm that one of the points we found actually is verified by plugging in. We can do any point we want, really. How about we use this point here, 3, negative 6, that very last one we found. So if I check this, I can use our simplified equation. I'm going to plug in that 3, and I'm going to hope I get negative 6. So y equals negative 3, the x value we're plugging in. And if I do negative 3 minus 3, then I can then confirm that y would equal a negative 6. So just to confirm, I plugged in a positive 3, I got a negative 6. So this is a good way of confirming yes, because that is that point on the graph that we found. So one more example before I let you try these on your own. Again, I see I have some solving work here, and before I can put this in mx plus b form, I need to get y by itself. So I'm going to go ahead and solve for y. The first thing I need to do then is subtract 5x from both sides. This will give me that 3y equals negative 5x and then a positive 6. And now I need to continue solving, so a little bit more work to do. I have to now divide by 3 on both sides, giving me the final equation, y equals negative 5 over 3. Notice I don't have to change that. X plus 6 over 3, which is 2. So we're in pretty good shape now. Let's see if we can identify first the slope, which is our m value being multiplied by x. That'd be negative 5 over 3. So negative 5 is our rise. And it looks like the 3 is the run. And then the y-intercept, quite simply, is our plus 2. So y-intercept equals a positive 2. So now I can start sketching. Y-intercept at positive 2, I can immediately plot this point right here by going up 2. I now need to listen to what the slope is telling me to do, which is to go down 5 for the rise. So I'm going to go down 5 from 2 all the way down to negative 3. And then the run is a positive 3, so I can go over 3. And there is our next point sitting right here. It looks like at 3, negative 3. And again, the problem is I don't have enough room. Oh, actually I do. I do have enough room if I wanted to, so why not do that? To go down 5 and over 3 again. So 1, 2, 3, 4, 5 down, over 3 one more time if we wanted to. I can get that next point right here. If I really want to, though, just to drive the point home, I don't have to write the slope as negative 5 over positive 3. I could write it as positive 5 over a negative 3. That's also negative 5 over 3. So this is telling me that I could actually go up 5 from 2, which would be put me here at 7, and then negative 3 would be left 3. I could even have a fourth point sitting right here at negative 3, 7. Because I actually noticed that all 4 of these points, if I sketch this, still all fall on the same line. Again, though, not a bad idea to check one of these points. It really doesn't matter which one we use. How about this point 3, negative 3, that first one we found? See if we can do this. So I can check. Now, I can use the y equals mx plus b equation. There's also nothing wrong, though, of going all the way back to this original equation if it's easier. And I think in this case, this might be easier for my checking purposes to see if I can plug in x is 3 and get the y negative 3. But it's totally up to you, whatever you want to plug into. So I'm going to go ahead and plug into that original. So 3y, and if I plug in x is 3, and I solve this equation for y, I'm hoping that I'm going to get that y equals negative 3. Well, let's see. If I simplify here, I end up with 3y plus 15 equals 6. Subtracting 15, I get 3y equals negative 9, and I can then take this one step further and find that y would equal negative 3, which is great because I was hoping to confirm from this whole thing that I get the point plugging in x is 3, getting y is negative 3, and that is exactly what we did. Good, so at this point I have 4 graphs I'd like you to try to sketch on your own, and then plot one of the points you find in, plug the x value in, confirm you get the y value just to make sure that that point seems logical, and then we'll check in on this next class.